The following inspections and procedures should be performed every 50 hours. At 50 hours, it is necessary to remove the spark plugs to inspect and re-gap them. Before removing the plugs, clean the area around the plugs to prevent dirt from contaminating any internal engine parts. Replace a plug at the first sign of damage or fouling. Note, use only direct replacement plugs. The central ceramic insulator should be a light tan in color. The outside barrel should be light charcoal to dark brown in color. The electrodes should have sharp, square edges. Do not change the heat range, and do not change to a non-resistor type plug. Damage to the ignition modules and to the engine can result from the use of incorrect spark plugs. Gap the plugs as per the engine manual specs. Check the security of the end cap onto the plug. Do not Loctite the end cap to the spark plug. Always clean and coat the threads of the spark plugs with a light film of anti-seize before installation. The engine mount rubber must be kept clean from oil and grease. Allowing the part to become contaminated will deteriorate the rubber over a short period of time, changing the alignment of the engine to the secondary. If it becomes necessary to change the engine mount rubber, remove the heat shielding between the engine and the exhaust. Support the engine using ropes or straps wrapped around the cylinder heads and around the airframe above the engine. Be careful not to apply any pressure on the pushrod tubes. Loosen and remove the 3 bolts holding the weldment and rubber. Replace the rubber and install with the exact number of shims. Verify the engine height by replacing a straight edge on the secondary and check the alignment of the engine pulley. Remember to make a mark 200 thousandths from the top of the engine pulley to verify the correct engine height. Refer to the engine installation section of the construction manual for other alignment procedures and further assistance. The main purpose of the tail boom in all conventional helicopters is to provide a mounting location for the anti-torque system or tail rotor. Its secondary purpose is to mount the vertical and horizontal trim fins, which are used to stabilize the aircraft in forward flight. The tail boom is subject to most of its stress during takeoff and landing. The skin and its associated parts are subject to high-frequency vibrations that can cause stress cracks and generate loose rivets and bolts. For this reason, it is important to retorque the following bolts at the 50-hour service point. Retorque the tail boom attachment bolts E00-2432 to 7 foot-pounds. Retorque the tail boom attachment bracket bolts E00-2308 to 4 foot-pounds. Retorque the horizontal trim fin bolts E00-2306 to 4 foot-pounds. Retorque the slider stringer cross brace bolts E00-2300 to 4 foot-pounds. Retorque the slider stringer bulkhead bolts E00-2303 to 4 foot-pounds. Inspect the area where the body panels contact the tail boom for any damage from chafing. Check the engine pulley for anodizing wear. Clean the main drive belts, engine pulley, and secondary pulley with a clean cloth, damp with acetone. Inspect the condition of all the coolant hoses. It will be necessary on some hoses to reposition or remove the fire-resistant hose to inspect the coolant hose and clamps. Note, the rubber hoses in the cooling system should normally be replaced at 250 hours, 5 years, or on condition, whichever comes first. Rotorway International recommends having the coolant solution tested once a year. This is a fairly common procedure and can be done by many auto parts stores or repair shops. The coolant should be replaced every 2 years or 250 hours, whichever comes first. After completion of the 50-hour service inspection, enter it into your engine and aircraft logbooks. Enter any parts that were changed on condition and log the Hobbs time. The following maintenance items are to be performed every 100 hours. To assist in performing the 100-hour service on your helicopter, Rotorway provides a 100-hour service parts kit that includes all the parts required for 100-hour changeout. At 100 hours, it is necessary to remove the spark plugs and replace them. Note, use only direct replacement plugs. Before removing the plugs, clean the area around the plugs to prevent dirt from contaminating any internal engine parts. Set the spark plug as per the engine manual specifications. Check the security of the end cap onto the plug. Do not use Loctite to secure the end cap to the spark plug. Always coat the threads of the spark plugs with a light film of anti-seize before installation. Torque the cylinder head bolts as shown earlier. The differential compression check or leak down test is a test of the condition of an engine cylinder. The amount of leakage past the piston rings and valves is determined by measuring the pressure drop across a calibrated orifice in the tester. This test must be performed every 100 hours. The tester used in this video is manufactured by Eastern Technology Corporation. This is their model E2. You can purchase this tester from Aircraft Spruce. Their phone number in California is 800-824-1930. The Aircraft Spruce part number is also E2. You will also need to order the 14 to 10 millimeter adapter part number 12-18201. Follow the manufacturer's instruction for the calibration of the tester for variances of air source. The leak down test should be performed after the engine has cooled down and its internal temperature has stabilized at 50 to 90 degrees Fahrenheit. Remove one spark plug from each cylinder. Locate top dead center for number 1 cylinder. This can be determined by valve position and timing marks on the flywheel. Confirm the intake and exhaust valves are closed on cylinder number 1. Refer to the Rotorway Maintenance video series Tape 1 for more information on finding top dead center in the valve lash adjustment segment. Install the adapter for the tester into the number 1 cylinder spark plug hole. Caution, it is possible that once the air source is applied and if the piston is not exactly at top dead center, the engine may rotate, causing the main rotor blades to rotate. Either perform this test in an area that allows the blades to rotate, or remove the blades. Before applying the air source, be sure all personnel and objects are clear of the drive system and tail rotor. Connect an air source of at least 90 psi to the tester. The left-hand gauge must read 0. Slowly adjust the regulator clockwise until air pressure locks piston at top dead center. Once the piston is locked, adjust the regulator so that 80 psi is registered on the left-hand gauge. The right-hand gauge indicates the relative pressure of the air remaining within the cylinder being tested. The reading on this gauge should be observed and recorded. Note, due to standard engine clearances and normal wear, no cylinder is expected to maintain a perfect 80 psi. It is important that all cylinders have a somewhat consistent reading. Good judgment should be used as to the allowable tolerance between cylinders. Rotorway International's engine specifications are as follows. Exec 90 engines allow up to 15% or a maximum 12 psi differential. Exec 162F engines allow up to 5 to 8% or a maximum 7 psi differential. If you determine a low pressure reading in the tested cylinder, then listen for air escaping in the following locations. With the tester hooked up, listening for air leakage at the tailpipe indicates a leaking exhaust valve. Listening at the plenum intake indicates leaking at the intake valve. Listening at the oil sump breather and valve cover area indicates leaking at the piston rings. Remember, some leakage by the piston rings is considered normal. The timing marks will be 180 degrees off for number 2 and number 4 cylinders. The firing order is 1, 2, 3, 4, so the next cylinder to test is number 4 when turning the engine counterclockwise with the flywheel tool. Once you have located top dead center for cylinder 4, make an index mark for future reference. Record the pressure readings in the 3-ring binder so you can maintain a history of your engine's differential cylinder pressure. Replace the fuel filter every 100 hours or on condition. Disconnect the battery leads before servicing the fuel system. Remove the fuel filter from the fuel tube mount. Check for fuel contamination by cutting the used filter in half and inspecting the inlet side of the filter element. If the element is contaminated, inspect and clean the pre-filter and the fuel shutoff valve filter assembly, as shown in the first 10 hours of operation. When installing the new filter, be sure to replace the 2 crush washers and note the proper flow direction. Remember to use a small amount of engine oil on the AN fittings. Install the fuel lines, then tighten the clamps. Be sure and do a fuel system pressure check to verify there are no leaks. The airframe is constructed of various sized tubes consisting of geometric shapes which will allow the airframe to flex at key areas during operation and still maintain a high structural integrity. The tubing is aircraft industrial standard 4130 chrome moly. The oxygen-acetylene gas method of welding is used, and all weldments are air-cooled to retain the original strength of the alloy. Remove all inspection panels, including the two upper rear fuselage panels that are held on by nut plates. Using a flashlight or suitable source of illumination and a mirror, inspect for cracks on the round and square tubes, paying close attention to the welded areas. If a small hairline crack appears, remove the paint from the airframe at that position to further verify the crack. It may be necessary to apply pressure or a load in such a manner as to help open up the crack to verify. If close inspection verifies the crack, contact the factory for further assistance. Remove skid pants. Inspect the rear landing gear, gear gusset, the area 6 inches above and below the landing gear step, and the rear landing gear attachment bracket. These are critical inspection areas. Approximately 80% of the total aircraft weight is transferred on the rear gear. Retorque these bolts on the rear landing gear E00-2601. Retorque these bolts on the front landing gear, E00-2415. Retorque these bolts on the engine mount, E00-2507. The material used for the tail boom skin is aircraft industry standard, grade T3 aluminum, and is 25 thousandths of an inch thick. The sheet is rolled in a cone shape to provide structural integrity. The tail boom is subject to most of its stress during takeoff and landing. The skin and its associated parts are subject to high-frequency vibrations that can cause stress cracks and generate loose rivets. Stress cracks. Upon inspection of the tail boom skin, if you find that stress cracks have started, drill a small hole at the very end of the crack. The size of the drilled hole will depend on the severity of the crack. This hole will stop any further migration of the crack. Note, a patch may be necessary depending on the length and size of the crack. Loose rivets. Using the appropriate sized drill bit, depending upon the size and head diameter of the rivet, Drill out the head of the rivet by rotating the drill in an elliptical manner. This will remove the head without drilling through the rivet hole. Then use a rivet shank or a small punch to knock out the remainder of the rivet. Clean the area and deburr the hole if necessary. Replace the rivet using the original type and size. Use a good quality commercial grade rivet for replacement. The body of the exact 162F helicopter consists of several separate panels that, when assembled, make up a solid egg-shaped structure. This provides for a very efficient and aerodynamic airflow. Each panel is made using the hand layup squeeze method to give the piece the maximum strength to weight ratio. A gel coat is applied to the mold prior to the fiberglass layup so that the parts are ready for light sanding and paint. Care of the body panels is very minimum. However, two factors which may damage them are heat and prolonged exposure to gas and oil from lack of cleaning. When doing pre- and post-flight inspections, avoid exposing any removed panels to excess heat or direct sunlight. Stand the panels upright and avoid placing them in an abnormal position. Prolonged exposure to excessive heat or sunlight in an abnormal position could result in a deformed panel. Fiberglass is resistant to most chemicals. However, panels that are exposed to gas and oil over long periods of time will eventually be weakened. Wipe off oil and gas with a dry cloth. Check to make sure that all metal parts protruding through the fiberglass have a minimum of 1/4 inch clearance. If the clearance requires enlarging, this process can be done by using a round or flat file or an air or electric grinder. Do not use a garden hose to wash and or rinse the helicopter. The pressure from the hose could get other parts of the helicopter contaminated with water. The helicopter must be kept clean and dry. Use a spray bottle and clean soft cloths to clean the helicopter. Use a good quality wax to protect the painted surfaces of your helicopter. Never store your helicopter out in the open or exposed to the elements. The Rotorway helicopter was not designed for this type of storage. Rotorway International has a custom lightweight and weatherproof cover available for the exact 162F helicopter. The cover is quick and easy to use. It has its own weatherproof bag and folds up small enough to be stored under your seat cushion. Also included is a cover for the tail rotor assembly. Call the parts department for more information. The Helipack, available from Rotorway, is a cargo pod that mounts beneath the helicopter's tub on rails fastened to the skid tubes. The Helipack measures 30 inches by 26 inches and has a capacity of approximately 7.4 cubic feet. Use care when cleaning the plexiglass parts. To clean the plexiglass, use a mild soap and water solution on a cloth to remove dirt and fingerprints. A plastic cleaner should be used to preserve and protect the windscreen and to bring up a high gloss. Care should be taken so that the windscreen screws are not over-tightened. You should be able to turn the windscreen screws with slight pressure. If the screws are too tight, They could cause stress cracks that may result in a major crack down or across the windscreen. If a stress crack appears, stop drill the crack with the appropriate size drill bit. Refer to Section 1 of the construction manuals, Working with Plexiglass. Use any commercially available upholstery cleaner on the seats or cabin interior if they become soiled. After inspection, reinstall the skid pants. Check to make sure that the skid pants do not chafe against the body tub of the landing gear. If contact is present, file the fiberglass skid pants to make clearance between the two parts. The tail rotor drive of the Exec 162F utilizes a V-belt design rather than a drive shaft with gearboxes to transmit power to the tail rotor. This design provides a simple and effective drivetrain with low maintenance. Make an index mark on both bearing plate slider rails, then loosen the 5/16" nuts on the tension rods enough to remove the idler pulleys from the mount scissors. Remove the pulley by removing the 3/8" bolt. Check the travel of the idler pulley assemblies. These must be able to pivot freely throughout their full range of travel in the bulkheads. Inspect for wear and anodizing on the pulley. Replace the temperature strips if they have come off or have lost their adhesiveness. Clean the 3 belts with a clean cloth, damp but not dripping with acetone. Also inspect for cables and wires that may have shifted or come loose in the tail boom, allowing them to rub on the pulley. Reinstall the idler pulleys. Do not tension the tail rotor drive belts at this time. Inspect the tail rotor pulley for wear and security. Clean the pulley with a cloth, damp with acetone. Inspect the bearings and this bolt for the proper end play. This bolt should be just tight enough so that the head of the bolt can be rotated slightly with your fingers. Inspect and check the male rod ends of the pitch links for wear. Remove the cotter pin, nut, the bolt part number E00-2311, and washers. Slide the actuator arm to one side and clean the bolt hole in the pivot casting. Inspect the rod end and the bolt of the directional control cable. Check the security of the cable housing to the cable mount tube weldment. Reassemble the actuator arm and place a film of grease on the bolt and bolt hole of the pivot casting. Install the bolt and nut. Replace the cotter pin with the new one. Retension the tail rotor belts by positioning the bearing slider plates back to their original position per your index marks. Verify the proper tail rotor belt tension with the tensioning tool. The control assemblies of the helicopter transfer control inputs from the pilot and passenger to the associated locations on the helicopter. The four areas that require control inputs are directional controls, cyclic controls, collective controls, and throttle controls. Coordinated inputs of these controls allow the pilot to maintain control of the helicopter throughout all maneuvers. Check for freedom of movement of the foot pedals. If you find that there is some binding, remove the bolt that secures the directional control cable to the pilot's scissors to determine if the binding is in the cross shaft or some other component. Inspect the freedom of travel of the directional control cable. Under no conditions should any type of lubrication or oil be used on the sliding inner cable. Inspect and check for play between the rod end and 3/16" bolt on the directional control cable. Check the security of the jam nut. Reinstall the rod end bolt to the foot pedal scissors and torque the bolt to 50 inch-pounds. Inspect and check for play and wear between the rod ends and 1/4 inch bolts on the scissors of the pilot and passenger foot pedals. Inspect the security of the jam nuts. Inspect the security of the foot pedal stops. Inspect the security and retorque the bolts that fasten the pilot's right pedal and the passenger's right pedal to the cross shaft. Check the freedom of travel of the cyclic in all control positions. If you note some binding or stiffness in cyclic control movement, disconnect the cable control T's at the swash plate. This will help you determine if the binding is in the cross shaft, cables, or some other component. If the cyclic moves freely with the swash plate disconnected, check the slider ball adjustment, which will be shown later in this 100-hour service under the rotor hub section. Check the bolts and the rod ends for the proper end play. Check the security of the jam nuts. Check the bias of the cyclic cables. If you notice any excess play, set the bias to eliminate the play. Tension one cable against the other with approximately a 4-pound pull with a spring scale. Check the security of the cyclic stop bolts and their jam nuts. Verify swash plate's degree of movement in relation to the cyclic handle. The helicopter's main shaft must be level fore and aft and laterally. The lateral cyclic's full movement is 52 degrees to the swash plate's 10 degrees. The full movement of fore aft cyclic is 52 degrees to the swash plate's 10 degrees. Refer to the final rigging section of the manual and video for more details. Check the freedom and range of travel of the collective control. Check the bolts and the rod ends for the proper end play. Check the security of the jam nuts. Check the security and condition of the collective control spring. Check the condition of the collective hand grips. Check the range and freedom of movement of the throttle components. Check the bolts and the rod ends for the proper end play. Check the security of the jam nuts. Check the ball end of the throttle cable and verify it does not catch inside the throttle cable clevis. The drivetrain is a series of reduction pulleys and sprockets that transmit power from the engine to the main rotor system. No transmissions, gearboxes, or drive shafts are used. The system is simple to monitor and maintain. Before servicing the oil bath of the drive system, carefully inspect all areas of the oil bath for any sign of an oil leak. Check the gasket all the way around the bath. Look under the main shaft lower bearing. And with a flashlight, look at the area beneath the rear seal. Loosen and slide the rain shield up and away from the top oil bath covers. Remove the rear oil bath cover. Note, if your helicopter kit was shipped after the spring of 1996, you should have the new oil bath covers with specially designed inner lip. This makes the removal and reinstallation of the rear cover much easier. Note, it is possible to change the chain and inspect the main sprocket by only removing the inspection window. Inspect the main drive sprocket for any noticeable wear around the teeth. First indication of wear will be an abnormal amount of aluminum flakes and dust on the oil bath floor and in the lubricant mix. Check the sprocket hub for backlash against the main shaft. This can be done by grabbing the main rotor shaft and applying pressure against the standard rotation of the rotor system. If you notice abnormal wear of the large sprocket, contact the factory for further inspection and instructions. Monitor the relationship of the main rotor shaft to the sprocket hub for any movement. Look at the 4 1/4 inch bolts that secure the hub to the sprocket for elongation. If any movement is apparent, contact the factory. Remove the master link clip and master link. Remove the chain. The chain and master link are a 100-hour changeout. A new chain is included with a 100-hour service kit. At this time, check the fit of the new chain. When installing the new chain, use the old master link as follows. Bring the two ends of the chain together at the secondary. Install the old master link from the top as shown. After verifying the fit and you are ready to finally install the chain, gently tap the old master link out with the new one and secure it with the clip. Using a straight edge, measure the deflection of the chain with a 10-pound pull from a spring scale. The chain should deflect 1/2 inch for proper tension. If your rear oil bath seal is not leaking and the replacement chain does not require to shim and move the secondary, then it may not be necessary to replace the seal. Should you find the chain does not have enough tension, it is possible to add a shim up to 25 thousandths of an inch between the square tube and the lower main shaft bearing flange shown here. Caution, be sure to loosen the bearing flange bolts and tap on the bearing to realign it to the shaft. Recheck the chain tension. If on the rare occasion that more than 25 thousandths of an inch shim is needed, it will be necessary to shim the secondary and replace the oil bath seal. The procedure to replace the oil bath seal is as follows. Remove the retainer plate. If your secondary has a keyway shaft, then it will be necessary to use a gear puller to remove the sprocket. If your secondary has a keyless shaft and uses a compression type sprocket, it must be removed using the following method. Before removing the sprocket, check the index mark you should have made on the shaft. Verify the sprocket hasn't rotated on the shaft. With the split and the locking assembly at the 12 o'clock position, loosen the bolts in this sequence. After each bolt has been loosened, back off the bolts and remove them and install 5 of the 6 bolts in the adjacent holes as shown. Following this sequence, turn each bolt equally until the locking device breaks free of the shaft. Remove the sprocket. With the heat gun, heat the surrounding area where the glue exists. Caution, use only enough heat to pop the seal up with a flat-bladed tool. If you have the keyway type shaft, before replacing the rear oil seal, an inspection of the secondary shaft in the area of the keyway should be done every 100 hours. Thoroughly clean the secondary shaft with solvent and acetone to remove oil. Use a penetrant inspection kit to detect any cracks, such as Magnaflex Spot Check test kit as shown here. This can be purchased from Aircraft Spruce. If you find any shaft cracks or damage, contact Rotorway customer service. Always protect the shaft with tape or a cardboard tube before sanding and cleaning the oil bath opening. Clean the lower oil bath pan seal opening area with acetone and lightly sand any glue or uneven protrusions from the pan. Sand mating surface of the seal with 400 grit paper and clean with acetone. Caution, do not touch the rubber seal with sandpaper. Place a little oil on the rubber seal and shaft. Mix blade glue at the proper ratios and apply to both parts. Verify the correct side is up, then slide the oil seal down the shaft, pressing down with light finger pressure until the seal seats on the oil bath. Do not add any pressure or set any weight on the seal. Allow the seal to seat itself into position. Wipe off excess glue with a dry rag. Let glue cure for 12 hours. Place a small amount of oil on the seal near the shaft before rotating the shaft. Install the secondary sprocket as per the construction manual and video. Use the same amount of shims under the retainer plate as your original installation. Verify the alignment of the secondary sprocket to the main sprocket. This alignment procedure will vary according to the type of shaft you have on your secondary. Refer to the construction manual, section 11, for the specific procedures. Torque the bolts and safety wire the secondary sprocket as per the construction print E23-2000. Install the new chain and master link. Never reuse the master link clip after it has been installed. Paint the master link clip for easier inspection. Using a straight edge, measure the deflection of the chain with a 10-pound pull from a spring scale. The chain should deflect 1/2 inch for proper tension. Check the security of the hose clamps on the safety spacer. If you are replacing the oil bath lubricant, thoroughly mix 1 quart of engine oil and 1 container of STP oil treatment. Pour the mixture into the oil bath and reinstall the oil bath cover.